So the definition of a log, it allows us to find a missing exponent in an exponential. So we read this as y equals log base A of x. And that is meaning, in exponential form, x equals a to the y power. So the base of the log is the same as the base in the exponential. So it's a to the y equals x. So a log is giving us the missing exponent, essentially. When you write these, the base is a subscript, so it should be a small number down there. So the first couple examples I want to do, just practice going back and forth between a log and an exponential and make sure we know how to go back and forth between the two. So I want to change each exponential into a log and each logarithm into an exponential. So A, 1.2 to the third equals m. So that's an exponential. I want to write it as a logarithm. I'm not asking you to solve anything yet. So we put log, log. The base of the exponential is the same as the base of the logarithm. So it would be log base 1.2. You go across the equal sign. So of m, and it's equal to the exponent, equals 3. All right, so b, e to the b power equals 9. How do you write that as a logarithm? Log base e of 9 equals b. C, I gave you a logarithm to start with, so I want an exponential. The base of the log is the base of the exponential, so it would be a to the 5th power equals 4. Log base e of b equals -3. How do we write that one? All right, so that's going to be 4 of your homework problems tonight. Just like that, just writing the definition. Are we okay with those? Okay. Let's practice evaluating logs. So I want to find the exact value on these. I'm asking you, what does log base 2 of 16 equal? Now there's different ways of doing this. You could change it to exponential form. So if we just said equals x, that means 2 to the x power equals 16. Didn't we just get done solving problems like this? Got a common base on each side. 16 is 2 to the 4th, and x is 4. That's one way. You might be able to look at this and just solve it. If you know what a logarithm means, the logarithm is the exponent. So it's like saying 2 to what power equals 16? 4. And so if you can see that, you could just write down 4. So B, this is like saying 3 to what power equals 1 over 27? -3. If you didn't know it, you could write it out, set it equal to x, and solve it. But if you think about that we're just looking for the exponent, we could evaluate it that way. Well, I might have missed. Did we already miss cross country? They're supposed to be there. All right. Back to this. So can you guys just look at C and tell me what the answer is?
0.
0. It means 2 to what power equals 1, which is 0. So if you can just look at it, that's great. If you can't, you could always set it equal to x and solve it like yesterday's problems. All right, this one, 5 to what power equals 25? 2. All right, can we handle these? So that's 2 problems on your homework tonight are just matching. It gives you problems like this, and it gives you answer choices, and we just match them. Can we handle that?
Yep, absolutely.
All right. So the last thing I want to talk about today is the graph. So how are an exponential and a log related? You guys remember talking about this at all last year? Okay. So if we think, well, actually, let's start with an exponential. So if I said y equals 2 to the x, that's an exponential, right? And if I told you guys to graph that, what would you do? Oh, you would not. Shame on you. What do we do?
Seems like
I have failed.
That's
We
what I
just-
teach her.
Yes, yes. And what 3 values do we have to plug in?
Make it 1, 0.
Oh, yeah.
Okay, we've got
just
this.
learned that.
So 2 to the negative 1 is 1/2. 2 to the 0. And 2 to the first is 2. Okay. So what if I asked you to graph log base 2 of x? So we set that equal to y. This is a little bit harder to think about, but we could change it to an exponential. If I change this to an exponential, what would it be? 2 to the y equals x. How are these two related? What happened? X and y flipped, right? Inverses. They are inverses of each other. When you go to graph this, you would plug in your -1, 0, and 1 for your y because it's the exponent. And then we get these for our x's. So all we're doing is flipping the x and the y. So let's try one and see what it actually looks like when we graph it. So f of x, same thing as y, equals log base 1/3 of x. So we would change it to exponential form. So it would be 1/3 to the y power equals x. So when you make your t-chart, which variable are you plugging your numbers in for? The y, because it's the exponent. What's 1/3 to the negative 1? 3. 1/3 to the 0. And 1/3 to the first. So let's graph them. So 3, -1, 1, 0, 1/3, 1. We could do more points, but it's going to look like this. Remember when we graphed exponentials, they always had a horizontal asymptote at 0? So inverses, the inverse or the log will have a vertical asymptote at 0. So it's going to look like this. Questions on that? Are you okay after?
Yeah. Just drop it.
Let's do a couple with transformations and then I'm done. So I have 2 examples left. If we need more, we can do more. If we've got them, then you can work. So I want to graph each of these, do domains and ranges. So my recommendation, just like when we did exponentials, we always graphed the parent function and did our transformations from there. My parent function is just log of x, so it would just be log base 3 of x. So in order to draw your graph, you have to change it to exponential. So it would be 3 to the y equals x. So then y is the exponent, so we put in -1, 0, and 1 for that. 3 to the -1, 3 to the 0, and 3 to the first. So I have 1/3, -1, 1, 0, 3, 1. It's my parent function. I have a vertical asymptote at 0, so it just looks like this. What does this plus 2 do to my graph? Left 2. It's inside, attached to the x, so it'll go left 2. When we graphed the exponentials, they had a horizontal asymptote, so when we moved them up and down, that asymptote moved. Now that we have a vertical, that will get shifted if we move left or right. So if I go left 2, my vertical asymptote is now at -2. Oh, that is very crooked. Okay. So then just take each of your points to the left 2. What is the domain of this? What's my range? Your range will always be everything on this. Your domain may get shifted. Is that one okay? B. What is my parent function? Just log base 4 of x, regular log base 4. What's this plus 2 going to do? We change this to exponential. We get 4 to the y equals x. So plug in -1, 0, and 1 for your y. 4 to the -1, 1/4. 4 to the 0 is 1, and 4 to the first is 4. So 1/4, -1, 1, 0, 4, 1. That's my original. And then we're going up 2 with each of these. So what should look like this? Domain? 0 to infinity, range. Are there any questions over these? So, if you haven't finished those interest problems from yesterday, those are also due on Monday. No, we don't have Wi-Fi, so I will pull them up and put them up here if you need them. And then from this section, it's not as many problems as it looks like. 1 and 2 are matching questions. 4 through 10 is just definition. 39 through 44 are all matching. So